Hello, this video is for three of you who are quarantining right now, and also for Joey who's working independently. I'm going to try and go through some stuff that I went through Friday in my afternoon class, and hopefully get you guys caught up with where we're supposed to be. The sound quality will probably not be all that great because I'm recording this on my computer at home and there's not a good microphone there. What we're going to be talking about today is technically the last part of Chapter 2, although for you guys it'll be on the tests that you have together with Chapter 3. And today we're basically going to take a trip back to junior high because we're going to talk about a topic you should have done back in about 7th or 8th grade. We're going to learn about stem and leaf plots. Stem and leaf plot is one of the quickest ways that you can organize numerical or quantitative data. And what happens when you do it is you basically use the numbers themselves to make a little bar graph, to make a histogram that shows you the kind of distribution that you have. So if you know how to make a stem and leaf plot, you can probably space off for the next few minutes, but if you don't, I'm going to real quickly review the rules. First off, there are two main parts to a number, what we call the stem and what we call the leaf. The stem is just the first part of the number. Most of the examples you're going to do will be two-digit numbers, and when that happens, the tens place is the stem. Now, if you have a number less than 10, the stem would be 0. If you have a number over 100, like 113, in that case the stem would be 11. But the stem's the first part of the number. And the leaf is just what comes after the stem. So like in the number 35, the stem's 3, the leaf is 5. We'll talk later about what you do if you have really big or really small numbers, but for most things that's how stem and leaf works. So officially the first step of making a stem and leaf plot is you draw a line down the middle of your paper. For most people, what that is the pink line on a piece of notebook paper. We're going to put the stems on one side of that line and the leaves on the other. On the left side of the line, you're going to put all of your stems in order from smallest to largest. And if you happen to be missing some numbers, you still write down those stems because what it's going to do is show us that that's where there's a gap. After each of the stems, we're going to write all the leaves that are associated with that stem. So like after a 3, I'd write the leaves for all the numbers that are in the 30s. When I'm doing that, I want to make sure that I sort the leaves out from smallest to largest. And if something repeats, you always write it down more than once to show how many times it repeats. I'm going to look at one example of making a real basic stem and leaf plot. You'll do 2 or 3 problems in your book that'll ask you to make some stem and leaf plots, and those tend to involve more numbers than this, but the process is the same. So here I've got a bunch of numbers. We're going to try and make a stem and leaf plot with them. First thing I want to do is to make a quick scan through my numbers and see if I can figure out what's the smallest and what's the largest. In these numbers, the smallest number is 17, the biggest one's 50, and so what that means is my stems should go from 1 to 5. So to start off the stem and leaf plot, I make a line, and on the left side I put 1, 2, 3, 4, 5 to stand for numbers in the 10s, 20s, 30s, 40s, and 50s. Now again, you might have noticed there wasn't anything in the 40s, but I still write down 4 to show that there'll be a gap there. And next I'm going to go to all the numbers that are in the teens. And I look at those, and I realize here I've got 2 different 17s and also a 19. So after the 1, I write 7, 7, 9 to show that I've got 2 17s and 1 19. I do basically the same thing for the 20s and 30s. In the 20s, I have 26, 28, and 21. I have to sort those out so that the smallest number comes first, which is why after the 2's I put 1, 6, 8. And similarly, after the 3, I put 5, 5 to show there were two 35s, and then 7, 9. Again, there are no 40s, so I just leave the space after the 4 blank, but there is a 50, that's why I put a 0 after the 5. And that's my completed stem and leaf plot. Here's just another version of the same thing. When you see a finished stem and leaf plot, it's a little bit easier to see things like what's the smallest number, what's the biggest number, where is there a gap, what kind of distribution do I have. There's all kinds of different things that can be told more easily when it's organized like this than when it's just a bunch of numbers. The main things we hope to accomplish by making a stem and leaf plot are sorting the data from smallest to largest, getting some sort of idea of what type of distribution you have, and finding gaps and outliers. For example, I might show you a stem and leaf plot like this and have you look at it for a minute and see if you can figure out what's the number that's the most common among the ages that are shown in the stem and leaf plot. What's the mode, the most common number? And hopefully you can tell looking through that the most common is going to be 4. 0, 4 if you look at the stem and the leaf. That ends up repeating 4 times, and while there are some others that repeat 3 times, that's the only one that's as often as 4 times. So 4 is the most common number. I can also see that, for instance, 1 is the smallest number and 66 would be the largest number. I might show you a stem and leaf plot like this one and ask you where is the biggest gap in this data. And there are a couple of gaps here, but it's pretty clear to see that the biggest one is between 65 and 115. And again, you can see on there how we do show numbers over 100. Another kind of question I might ask would be, what sort of distribution are you looking at in this stem and leaf plot? Is it normal or uniform or skewed or bimodal? Sometimes there's more than one possible answer, but on this one I think by far the best would be skewed, because there's a lot more things down at the bottom than there are up at the top of this graph. One of the most common questions people have is, what if you don't just have easy numbers? And I will tell you, the examples you're going to do in the book, they basically are easy numbers. But if they aren't, what you basically do is what in science class they would call rounding to 2 significant digits. You take all the numbers, you find 2 significant digits, and you make a stem and leaf plot based on those, making sure that things are labeled to show what you're doing. The end result might look something like this. And I might show you on a test or a worksheet a stem and leaf plot that's labeled like this and ask you a question like, what's the largest number in this data? And the thing that's most important here is that legend at the bottom that tells you that 1, 2 doesn't stand for 12, it stands for 120 million. That's why I know the largest number, 6, 3, is going to be 630 million. I might also ask you what's the most common number, and that's going to end up being 310 million. One other thing I want to talk about quickly with stem and leaf plots is what's called a back-to-back stem and leaf plot. This is something that allows you to compare 2 different sets of data at the same time. Here's a back-to-back stem and leaf plot that's looking at the heights of players on a women's basketball team and a men's basketball team. And the important thing about this is that the men read the way you'd normally read it. I can look at that, and looking at the stem and the leaves over on the right, I can tell the shortest man is 72 inches tall. The tallest man is 85 inches tall. The important thing, though, is that the women read backwards. The shortest woman is 65 inches tall. The second shortest woman would be 68 inches tall. The stem's in the middle, and I read over to the left to find the leaves. If you find the tallest woman, she's going to be 77 inches tall. And the second tallest woman would be 76 inches tall. So the women here I read backwards, the men I read forwards. I'm going to mention in the video one other thing that will be helpful to you when you're making stem and leaf plots for the assignment that you have, and that's how you can use a calculator to sort data. We're actually going to talk about this Tuesday in the 7th period class. You have some problems where there's a whole big bunch of numbers, and it's a lot easier if you can let the calculator sort those rather than trying to go through and do it yourself. However, to learn how to do this, we're going to use a short, easy set of numbers that I can do pretty quickly, 7, 5, 1, 2, 3, 2, 6, 4. We're going to put those in the calculator and let it sort it out so that the smallest one comes first and the largest one comes last. I think all of the people this video is intended for have actually worked with stats mode on your calculator before, but just to refresh your memory, what you want to do is to first of all hit Stat on your calculator, and then in the Stat menu you want to choose Edit, which you do by just hitting the Enter key. If there happen to be any numbers in there, you've got to clear those out first. And the way you do that is you first of all hit the up arrow. That'll highlight the name of the list. And then you hit Clear and Enter to clear out all the data that's in there. Once you've done that, you should be left with nothing in list 1, and you can start fresh with the list of numbers you have. And what we're going to do is type all these numbers into list number 1, and I do that by just entering each number and hitting Enter after I've entered it. On the screen, you can see the 7 and the 5 got cut off when I went further down on there, but I do just type 7, enter, 5, enter, 1, enter, 2, enter, 3, enter, 2, enter, 6, enter, 4, enter, so that they're all in that list. Once you have all the numbers in your list in there, you want to hit Second, Quit, so that you get back to the main screen and you don't screw up anything else in your list. Second, of course, is on the left side of your calculator, and Quit is just the key right next to second. And then to actually sort these, what we're going to do is go back into stat mode. And this time, what I want to do is, on that main stat screen, choose choice number 2. You can either use your down arrow or you can just type 2, and then hit Enter to select that. That's going to put Sort A on your main screen. You, however, have to tell the calculator which list you want to sort. And the way you do that is you hit Second and then the 1 key. So you can see on the screen it says Sort A L1. And you hit Enter. It's going to look like it didn't do anything, but it'll say Done. And it will have sorted your list. You go back to Stat Edit, you're going to see that the numbers are all in order, 1, 2, 2, 3, 4, 5, 6, and down at the bottom there'll be a 7. So all of those numbers are now sorted out, and it would be a lot easier to make that stem and leaf plot if I have my numbers in order when I start. And again, the basic process, once you've got your numbers in list number 1, is you hit Stat, choose Sort A, which is choice number 2. That stands for sort in ascending order from smallest to largest. Hit Enter, hit Second 1 to put L1 on the screen, and hit Enter again. And that'll sort out all the numbers that are in your list, so it makes it a little bit easier to make a stem and leaf plot. So that's the basics of stem and leaf plots. You will want to check Google Classroom for the assignment that goes with this. If you don't have your book with you, I'll try and get a scan of that available so that you can get things straight from there. And that'll be it for this video. There will be at least one more coming up later in the week.